Namaskar friends, welcome to Rajan George Home's next episode. I am Rajan George. I am an IIT MTech holder and a builder. I have got long experience in building design and construction. Today I am going to speak to you about the method of construction of foundation when the soil is loose. The three typical cases for medium soil is, one is we get strong lateritic soil or very strong soil. Second is everywhere it is loose. Third case is some portion there is a very strong soil and some other portion it is loose. In these three cases, the foundation treatment has to be different. And the fourth case is the clay soil. Clay soil, the foundation methods are entirely different. For that, soil testing is required to ascertain the bearing capacity or the N value of the clay. But in ordinary soil, sandy soil, there is no need of any testing because testing is costly. It will cost 25,000 rupees and above. So, the low cost testing is first make the set outing of the house. Then, where there is no wall, you make 3 or 4 excavations at different points. It should not be where the wall comes, because if the wall portion is excavated, when it is refilled, it won't be sufficiently compacted to the original position. The excavation by Hitachi can be either inside the rooms or outside the rooms. When you make 3-4 pits 7 feet deep, you get an idea of the soil structure. Either we get very strong everywhere, that is 2 feet we get very strong, then most probably we will get very strong soil at 4 feet, 5 feet, etc. Then always go for the strong soil everywhere. The second case is the whole soil is loose or it is a filled up soil. Filled up for a depth of 5 feet, 10 feet or 15 feet like that. Today I am giving the foundation method and the cost calculation for this type of loose foundation or filled up foundation. First, what is to be done is, by Hitachi, make an excavation at 3 feet width and 3 feet depth, and it should be all throughout the wall length. For 1,500 square feet ground floor area, I am giving the calculations. The earthwork Hitachi cost will be approximately 15,000 rupees. When it is excavated, the next step is sand piling. By iron bar, you have to make pit in the ground, in the foundation, at intervals of 6 inches to 9 inches. And the pit will go down for 1 feet, 2 feet or 3 feet according to how loose the soil is, and it will form an inverted cone shape. And in the pits you have to fill baby metal or 6mm metal, and when filling the pits you have to ascertain that one hole is taken and that is filled before the next pit is taken, because if you take the next pit without filling the first pit, the first pit will become narrow. So the sand piling will make the soil double strong, or the bearing capacity or the strength of the soil will immediately become double. After sand piling, compact it. Then the next method is PCC. What is to be done is, in the 90 centimeter or 3 feet width of the foundation, have a PCC of 15 centimeter depth, 1:8 or better 1:3:6 ratio concrete. And while you make PCC, in the same day you have to make rubble construction over that for a depth of 1 feet. If you make concrete and make rubble construction after a few days, this PCC will be cracked and the strength will be reduced. And wherever you give PCC, all these portions, you have to fill it with the rubble the same day. So for PCC, the cost is for a 1500 square feet building, metal 476 cubic feet, cost is 23,800, sand 350 cubic feet, 17,500, cement 47 bags, 20,000, and labor 20,000. So the total cost of PCC will be 81,300. Next, let us see the cost of rubble. The cost of rubble for a 100 meter length foundation is 100 into 0.9 into 0.3, 27 m cube for the first portion. Then reduce the width of the foundation to 60 centimeter. That portion 100 into 0.6 into 0.45, it is 27 m cube. And then basement 100 meter length, 45 centimeter width, 35 centimeter depth, it is 15.75 m cube. Total rubble is 69.75 m cube. Rubble has to be filled with baby metal, cement and sand, all throughout the rubble in the gaps. That is called a rubble concrete. About rubble concrete, I have given another video. So the total cost of the rubble concrete is 69.75 m cube. That means into 35.315 equals 2,463 cubic feet. So the cost of rubble is 21 load, it is 6,500 rupees each, 136,500. Then labor at the rate of 40 rupees per cubic feet, it is 98,520. Cement 63 bag, 26,500. Then 6 mm metal, 600 cubic feet, 30,000. Sand 500 cubic feet, 25,000 rupees. The total cost of rubble concrete is 3,16,520. So when the rubble concrete is constructed, the next step is to fill the basement with the earth. Approximately it will cost around 7,000 rupees on the assumption that you have sufficient earth in the plot itself. You don't need to purchase it. So what is to be done is, always get the house plot above the road level. You will always have excess soil or earth to fill. Cost will be minimum. And once it is filled with the earth, and next step is to have a concrete belt. Concrete belt can be minimum 30 centimeter width, and it can be better in the whole width of the foundation 45 centimeter. For an average width 15 centimeter height, I am giving the cost. It will cost 500 kilogram of steel, cost is 37,500 rupees, and cement 30 bag 12,600 rupees. Then metal 160 cubic feet, that is 8,000 rupees. M sand 7,200 rupees. For belt, for RCC, you have to use M sand only, that is washed sand. For rubble concrete, you can use sand without washing. Then labor, it is 37,000 rupees. So the total cost of the belt is 1,02,300. Now let us see the total cost. First, the Hitachi cost 15,000 rupees. The sand piling will cost 35,000. The PCC will cost 81,300. The rubble concrete will cost 316,520. Earth filling 7,000. Belt 1,02,300. Then next portion is you require column for the sit out. Minimum 2 columns will come. For the sit out column, you have to start from the bottom soil, not from the belt. All other columns, in between columns, you can start from the belt. So the 2 columns for the sit out will cost approximately 30,000 rupees. So the total cost is 5,87,000 rupees and 120. So here in this method, I have explained to you how we can make a very safe foundation in a filled up soil, whatever be the depth of the filling. By this method, we can have a safe foundation. Or in any soil, that is sandy soil, not clay soil. In any soil where all throughout the length of the foundation, the soil is loose. Don't do this foundation when some portion of the building is very strong laterite and some other portion is loose. There the situation or the treatment is different. So this is the foundation method for loose soil. First method. The second method is inverted T-beam foundation. That is, in the shape of an inverted T of English letter, we make concrete foundation all throughout the wall length. That I will explain in another video. Thank you.